Hello friends, in this video we will learn about how to apply Newton's first law when the object is moving with a constant velocity over an inclined plane. So the objective of this session is to analyze equilibrium of bodies connected by cable and pulley. And this we will illustrate using a problem. So this problem says block of granite are to be hauled up a 15-degree slope out of a quarry. So this is block of granite and this has to be hauled up. And the dirt is to be dumped into the quarry to fill up the old holes. And the dirt whatever we have, and this dirt has to be pulled down and it has to be filled into the old holes. To simplify the process, you have to make some assumption. And what is the assumption and what is the design you are going to make? You design a system in which a granite block on a cart with a steel wheels, weight W1 including both cart and block. So the weight of cart and block is given. So this is and on a steel rails also. So all this has a weight of W1. So wheels is a steel wheels and the weight of cart plus wheel plus this granite block, all this comes out to be W1. And this is to be pulled up a hill on a steel rails by dirt filled bucket. So this is going up on a steel rails, and how this goes, and this goes because of this bucket that is filled with the dirt. Weight W2 including both dirt and the bucket. So the weight of bucket plus dirt is given, that is equals to W2. That descends vertically into the quarry. So this bucket plus dirt system descends into the quarry. How must the weight W1 and W2 be related in order for the system to move with a constant speed? So our target variable is to find what is the relation between W1 and W2 so that this system moves with a constant velocity. So this is given, that is moving with a constant velocity. Ignore friction in the pulley and wheels and ignore weight of the cable. So you have to make some assumption, that is ignore any kind of friction and ignore weight of these cables also. So how will you solve this problem? So first you have to make an initial setup, and that is what are the things that is given. So you have been given this angle, let's call this angle as theta. So theta is given, this is equals to 15 degree. Weight W1 is given and this weight W2 is given, and it has been given that is this system is moving with a constant velocity. This means this is in equilibrium. So we can apply Newton's first law. If system is in equilibrium, the sum of total forces is equals to 0 on a bucket as well as on the cart plus granite block system. So the idea to solve this problem is first we have to idealize. That is, this is my system and I have to make some idealization. And then I will draw the free body diagram. We will draw free body diagram for cart, that is block plus cart system, and another free body diagram we will make for bucket, that is W2. And then we will write equations. And once you have this equation, we can solve this equation, then we can find what is the relation between W1 and W2. So this is the idealized system. So I can show this cart plus granite block something like this and the bucket something like this. And this is the idealized system, and then I can assume there is a pulley and this is connected, the cables are connected and passing over the pulley. So I have to draw the free body diagram. So let us first show this cart plus granite. So I am showing this here. So this is the free body diagram of cart. So let us first draw free body diagram for cart. So what are the forces that is acting on this cart? The first force that is acting is weight. that will act in the downward direction, and this is W1. Now this rail will apply a normal reaction that is perpendicular to the incline, and this normal reaction is N. Since there is no friction, we can say there is no friction force acting along the parallel direction of the incline. But this is trying to pull this. So there is a tension force that is acting in this direction. So a tension force that is in the cable that will act in this direction. So this is my tension force, this is my W, and this is my normal reaction that is acting on the cart plus block system. Now similarly, I can draw free body diagram for the bucket. So let us draw free body diagram for bucket. So this is my bucket. I can show using a point mass. And what are the forces that is acting on this bucket? The first force acting in the downward direction is its weight, that is W2. And this cable is trying to pull this up. So there is a force that is acting in the upward direction, that is tension T. Remember, this tension and this tension is same because we are assuming that this is a cable that has no mass. That is massless cable, massless string. So whenever you have a massless string, you will have same tension throughout the string, and that's why this tension is T at this point of time also. So how will you solve this problem? Before solving this, you have to first resolve the component along the incline and perpendicular to the incline. So you remember, whenever we solve problem on inclined plane, what we do is we resolve or we take the components of forces along the inclined plane and perpendicular to the inclined plane. So we have to take something like this. So this is the direction perpendicular to incline, and this is the direction that is along the incline. So let's call this as the x-axis, and this is my y-axis. So I have to resolve this forces. Now this angle is 15 degree, so this angle will also be 15 degree. You can basically prove. So this angle is 15 degree. So W1 will have one component in this direction, and that will be W1 cos 15 degree. Now another component of W1 will come in this direction, and that will be W1 sine 15 degree. Now we don't have to consider this now because we have taken the component, and that's why we are making a bigly sign. Now we have our free body diagram ready. Now this system is in equilibrium. So we can write Newton's first law. Let us first write for bucket. Now in the bucket, there is no force that is acting in the x direction. So this is my x direction, and this is my y direction for bucket. So on bucket, only forces are acting in the y direction. So what are the forces? In the upward direction we have force T, and the downward direction we have W2. So this is downward direction, that's why we have to take a negative sign. And sum of all the forces is equals to 0 because this system is in equilibrium, because this is moving with a constant velocity, acceleration is 0, and this is basically equilibrium situation from the Newton's first law. So from here I can write T is equals to W2. So let us call this as equation 1. Now similarly I can write equation for cart. So let us write equations for cart. So what are the forces that is acting on the cart? First let us write along the x direction, that is summation of fx is equals to 0. So this will give me the forces along the x direction. One force is acting along the x direction is T, and the negative x direction is W1 sine 15 degrees. So this will be negative, that is W1 sine 15 degree. And once again, sum of these forces is equals to 0. So this is one equation. Similarly, I can write another equation, that is summation of Fy is equals to 0, and this will give me the forces along the bidirection. Along the bidirection we have normal reaction plus, and this force is along the negative bidirection, that is minus W1 cos 15 degree. So this is equals to 0. So this is my equation 2 and this is my equation 3. So from equation 2 I can write, from equation 2 I can write T is equals to W1 sine 15 degree. Now if you remember, what is my target variable? My target variable is to find a relationship between W1 and W2. So now from this, that is equation 1, I can equate T. So this is T is equals to W1 sine 15 degree, and which is same as equals to W2. So I can write W2 is equals to W1 sine 15 degree. So this is the relation between W1 and W2, so that this system will move with a constant velocity. If you put the value of sine 15 degree, you can write W2 is equals to 0.26 W1. So W2 has to be equals to 0.26 W1, so that this system will move with a constant velocity. We have another equation, that is equation number 3. This equation will give you the normal reaction. So if you want to calculate normal reaction, you can write normal reaction is equals to W1, and this is cos 15 degree. So this is cos 15 degree. So this reaction will be helpful to calculate the normal reaction that is acting on this block, granite block and cart system. So one important point, this analysis basically does not account for the direction of motion. That is, your bucket can either go in the downward direction or it can go in the upward direction. What I mean, this means this system can either move in this direction, or even if this system is moving in this direction, you will have same relationship. That is, this does not account for the direction of motion. So when you have W2 is equals to 0.26 W1, it can move in both directions, either up or down. So this is the situation when we have W2 is equals to 0.26 W1. This can move either up or it can also move either down. So I can show something like this. This can move up or it can also move down. For both directions, this is satisfied. Now what will happen if W2 is greater than 26% of W1? In this case, what will happen? So this is W2 and this is W1. So W2 is greater than 26% of W1. So this means this side is heavy. So this means this whole system will move up. So this case you can say this system will move up. Now what will happen if W2 is basically less than 26% of W1? This means this time this is lighter and this whole system will move in this direction and the cart will go in the downward direction. So I can say in this case this will move, the cart will move in the downward direction. So to summarize, if you have W2 is equals to 26% of W1, in that case cart can move either up or cart can either move downward direction. If W2 is greater than 26% of W1, in that case cart has to move in the upward direction. And finally, if W2 is less than 26% W1, in that case cart will move in the downward direction. So in this video we learned how to apply Newton's first law when the object is moving with a constant velocity over the inclined plane. Hope you like this video, and if you like, then please share with your friends and among your colleagues, and I will see you in the next video. Thank you.